Since its establishment in 1948, the State of Israel has struggled to keep militants from its surrounding countries out of its borders. Recently, Israel has developed a robotic sniper to keep militants from the Gaza Strip from crossing the border into Israel. The new weapon, armed with a 7.62 caliber machine gun, has raised a few ethical questions. Can a machine lacking compassion sort through ethical dilemmas appropriately? Can the machines be programmed in a way to prevent loss of control on the battlefield? Is it ethical to allow a machine to harvest a human life without a conscious human decision to do so?
The first issue we came up with was machines lack compassion that humans possess and aren't able to adjust and adapt through difficult ethical alternative decisions such as the use for killing since it crosses a moral threshold. In our analysis, we discovered that it violates the ACM 1.2 Code of Ethics Avoid of Harm, which stands for well-intended actions, including those that accomplish assigned duties, may lead to harm. When the harm is intended, those responsible are obliged to undo or mitigate the harm as much as possible. Avoiding harm begins with careful consideration of potential impacts on all those affected by decisions. When harm is an intentional part of the system, those responsible are obligated to ensure that the harm is ethically justified. In either case, ensure that all harm is minimized. It also violates utilitarianism, which is the most ethical decision is one that creates the greatest good for the greatest number of people. The use of robo-snipers and suicide drones will cause more harm than benefits to society because they lack emotions, such as compassion, and cannot adequately sort through difficult ethical situations. For example, they may be unable to correctly determine who is an enemy and who is an ally, as well as who might be a civilian versus someone being a spy. For the modifications, we have proposed agreeing on best practices and having greater transparency for the design, testing, and use of autonomous weapons.
Let's now move on to our second ethical issue. This issue concerns the ethical dilemma with programming options and how to calibrate errors in decision-making that can prove to be very dangerous. If autonomous weapons are not programmed correctly, it could likely lead to a loss of control in the battlefield due to these weapons being smart machines. Automation is good at many things, precision, reliability, and speed among them, but autonomous systems are brittle. They lack the flexibility that humans have to adapt to novel situations. From an operational standpoint, autonomous weapons pose a novel risk of mass fratricide, with large numbers of weapons turning on friendly forces or innocent civilians. This could be because of hacking, enemy behavioral manipulation, unexpected interactions with the environment, or simple malfunctions or software errors. Furthermore, as the complexity of the system increases, it becomes increasingly difficult to verify the system's behavior under all possible conditions. To analyze this issue, we took into consideration some principles from the ACM Code of Ethics as well as utilitarianism. Section 2.1 of the ACM Code of Ethics encourages professionals to strive to achieve a high quality in both the process and products of professional work. In specific, professionals should be cognizant of any serious negative consequences affecting any stakeholder that may result from poor quality work and should resist inducements to neglect this responsibility. Considering the potential dangers involved in deploying autonomous weapons in a warlike situation, programmers must work with the utmost care to ensure robo-snipers and drones work as intended and do not target friendly forces or innocent civilians. Furthermore, Section 2.2 of the ACM Code of Ethics is as follows: to maintain high standards of professional competence, conduct, and ethical practice. Professional competence starts with the technical knowledge and with awareness of the social context in which their work may be deployed. Similarly, professionals creating these weapons must be well equipped with the technological skills necessary to carry out such a complex task, as well as understanding both the seriousness and ethical concerns involved with sending their work out into the battlefield. Finally, we looked at utilitarianism to better understand the gravity of programming errors in autonomous weapons. Utilitarianism is the view that an action is right if it maximizes the total amount of happiness in the world, counting everybody's happiness equally. With respect to our topic, if these autonomous weapon systems have program-related errors which cause the bots to go haywire, they can be very harmful to many people in the surrounding areas of warfare. Through this lens, we would advocate against fully autonomous weapons due to the high risk they possess. At the same time, however, if bots are being deployed in times of war instead of human soldiers, it could dramatically reduce the lives lost on the battlefield. As you can see, this is a very complicated matter with many possibilities to consider. So how can we possibly mitigate this concern? This is a very complicated program for professionals to create safely, but can be done effectively with little error. Machine learning algorithms and computer vision methods are only as effective as the training data used to train the models. Artificial intelligence needs extensive amounts of training to be able to distinguish items from one another and to work as intended. For example, if an enemy waves a white flag on the battlefield, will the autonomous weapon understand that the target is surrendering, or will it proceed with firing since it is an identified enemy? Therefore, one of the biggest ways to mitigate this concern is with effective testing methodologies and comprehensive data sets. Autonomous weapons must be trained for all possible circumstances and be able to adapt to novel situations in the event a scenario is not explicitly programmed for. These risks can be mitigated to some extent through better system design, software verification and validation, test and evaluation, and user training. Although the risks of accidents can be reduced, they can never be entirely eliminated. Moreover, a closely related aspect is that it remains unclear who would be legally accountable if civilians were unlawfully injured or killed by autonomous weapon systems, especially because targeting processes in modern militaries are such an immensely complex and strategic endeavor. With this in mind, and to decrease the chance of error, it would be safest to deploy semi-autonomous weapons rather than fully autonomous. With semi-autonomous weapons, human operators are required to make the final decision, rather than letting the machine do it itself. This would further establish accountability if a mistake was made and innocent lives were taken as a result of using these weapons. Finally, another way to lessen this concern would be for the autonomous weapons to have a possible kill switch. In the event a weapon starts to behave uncontrollably, it can be terminated safely and quickly so as to minimize total damages done.
In regards to the dilemmas surrounding Israeli robo-snipers along the Israel-Palestinian border, one of the main issues discussed in the article is it ethical to allow a machine to harvest human life without a conscious human decision to do so? For individuals like myself, a machine that has the power to fire and forget based off an algorithmic decision violates life and the concept of human dignity, while creating a slippery slope of liability to the human decision makers surrounding the topics of morality and responsibility of life. In order to analyze decision-making in regards to the creation of the robo-sniper, we must conclude to the ACM Code of Ethics in regards to the operation and determination of the machine. ACM 2.5 states that a system of which future risks cannot be reliably predicted requires frequent reassessment of risks as the system evolves in use or should not be deployed. Any issue that might result in major risks must be reported to appropriate parties. This code plays a major role in the creation of the robo-sniper and provides an extensive screening process to developers of the system and extreme training of individuals who potentially can operate it. Due to the rapid development of autonomous weapons, there is little to no international law that regulates the product or sale of these products. From the ethical standpoint, the formula of universal law states that we must be taken into action when deciding the future governance of autonomous kill machines. The formula of universal law states we can only act in accordance with maxims that you can at the same time will as universal law. Use people as a means rather than a means to an end. For this example, there's a major contradiction in conception, as us as humans cannot conceptually think or will ourselves in a world where robo-snipers and drones are the main participants in carryouts and during the acts of war. The contradiction of will is that we do not necessarily will ourselves or want to live in a world where this is the predominant norm of battle. In terms of modifications, as the future autonomous warfare continues to be a necessary evil that we have to discuss, there's a few modifications that we can use to solve this potential ethical dilemma. We conclude that autonomous machines require an element of human accountability that is only distributed through an extensive vetting process of potential users that is reserved to individuals throughout the highest ranks of the Israeli task force. In order to truly carry out this task, we believe that there must be a co-agreement between the international humanitarian law, defense companies, and military to publish an extensive training or class program that highlights the aspects of the human-machine interaction of the robo-sniper machines. This must be reserved to a select few who understand the national humanitarian law and who are battle-tested with a deep understanding of these ethics. In regards to the modification or towards the creators of the machine, there must be a significant partnership behind the defense industry and thought leaders behind ethics across the globe. The research and pre-development process must force defense companies to take extreme ownership and include understanding of the political direction of these developers, extensive research of non-harm to civilians, alongside an in-depth user manual that highlights the effective training of the deployment, command and control, and post-use assessment of the robo-sniper. By utilizing these mechanisms as screeners for the project, there can be a better understanding for humans on the impact of the machines that they will utilize.
Developments in defense technology have led to a new era of modern warfare. Modern weapons have raised ethical issues that couldn't have existed prior to the application of programmable computer technology. Moving forward, countries will have to answer these ethical concerns and take special care to comply with the Code of Ethics.